Good afternoon, good evening to all of our colleagues from across the ADA markets. Welcome to today's webinar on the data science behind ADA. I'm George, the head of data science and engineering for ADA Group. So what I want to do is I want to start by introducing us to the agenda for today's webinar. So what we're going to do today is start by discussing a little bit about how the ADA Exact team, which is the team behind our data management platform, and how we're positioned within the ADA group. And I also want to talk a little bit about the ADA's entire EdTech scope, because ADA Exact is not the only tech platform within ADA's tech portfolio. And then we will go on to discuss Exact proper, and we'll go on into some level of detail, first discussing the reach and scope of the Exact solution, and also to give you a better understanding of the data sources behind Exact. Then I wanted to discuss a little bit about the kinds of data that you'll be working with, which is mostly the syndicated segments that are available in ADA Exact, as well as something that we are working on right now, the engineering team is working on it right now, which is the user propensity scores. This is something that is a real differentiating factor for our DMP against our competitors. I then want to go into some level of detail about how the methodology that we use to fuse complementary data sets within ADA Exact. Now, one of the things that, again, differentiate us from our competitors is that we have multiple curated high-quality data sources. Notably, we ingest data from our various telco partners, which are a very important data source for us. And there is a very specific methodology in which we do that. So I'd like to give you some idea of that. And then related to this, I also want to talk about one very common modeling methodology which is used in mainstream DMPs called lookalike modeling. Now, ADA Exact also employs lookalike modeling whenever it's appropriate, but for most part, we think that lookalike modeling will introduce inaccuracy in user targeting. And so instead of lookalike modeling, we use a method called propensity scoring, which is a technique within the general field of supervised machine learning. And I want to discuss, help you to understand the difference between lookalike modeling and propensity scoring, and why that is significant for our competitive differentiation. And then finally, I want to close with a comparison between mainstream DMPs and ADA Exact, summarizing our competitive differentiation, okay? Now, because we're anticipating a rather large number of people joining this call, we will not be able to take questions live, but I've created a Slack channel, which I will introduce at the end of this presentation. So if you have comments and questions about this presentation, you are invited to post your comments and questions on the Slack channel, and either myself or members of my engineering team will try our best to respond to your questions and comments. Okay, so let's get right to it. Now, the ADA Exact team plays a very important supporting role in helping ADA capture a significant share of the digital advertising market. And we do this in kind of 3 steps. The first step is to really lay the foundation of success by building an immense and rich database of consumers. Now, often Exact is depicted as an audience database, and that is correct. But in addition to having a large database of audiences, of consumers, we're also interested in their consumption context. And in our case, the consumption context is mostly the location that the consumer is in. So in addition to building an audience database, the ADA engineering team is also interested in building a location database or geospatial database that provides the context of the behavior events of these consumers. And then the other important portion of ADA Exact is the campaign database. Now, in order to accurately infer what works and what doesn't work when it comes to marketing interventions targeted at consumers, it's very important for us to have a permanent record of every single campaign that we have run against targeted segments, and then have a very clear, have a very accurate record of the responses of those campaigns. So these responses have to be at the consumer level, and this will allow us to make user response predictions. Right? So having established this foundation, the next step is to actually use this data within the database to build accurate and reliable models of 3 things. We want to model what consumers prefer, what actions they will take, in other words, user response prediction, and then how to market to them optimally. Now, this last part about marketing to them optimally refers to a work stream which we call decision optimization. Basically, the problem statement for decision optimization is, given a marketing budget, given a media budget from a client, how can we distribute it across media types and across time, and using what kind of interventions in order to maximize user responses? So that's the problem of decision optimization, which is actually, you can think of it as the penultimate goal of ADA Exact. And then finally, of course, clients do not buy models, and they very rarely buy raw data from us. So what clients want to buy is insights and outcomes. And so we need to monetize these models and our database through a catalog of use cases or products that offer market insights or media buying services or outcome-based marketing services. All right. So this is the kind of the 3-step process in which we try to extract value from ADA Exact. So it may surprise some of you that actually ADA Exact is not the only tech platform that we're building, actually. So ADA includes the sell side business or the telco media business of our telco partners, and this is encapsulated in a brand called ADA Reach. And what powers this business is these supply side tools, which is the ADA Reach platform, and that is included in our tech stack as well. So the complete tech stack of ADA includes Exact, which is the primary project that I'm working on right now. But it also includes demand side tools, notably the Ad Parlor, social media placement tool, which we have licensed from Ad Parlor Inc. But along with that, we're also now thinking of developing additional demand side tools, including our own DSP and Decision Optimizer, which is like a meta DSP. Now, in existence right now in 3 of the telcos which we are partnering, our advertising business, are partnering, the three of the telcos which we are partnering for our advertising business. We have now taken over the telco media platforms, which are mostly push notification platforms. This includes SMS-based notification and MMS-based notification and so on. These form our supply-side tool component of our ad tech stack. There is a plan in maybe the later part of this year to kind of overhaul this portion of our tech stack, so that we can not only make telco media programmatic, but also to have, to introduce the possibility of onboarding other forms of media like TV, like programmatic TV, all right, in future. So I understand that there is a question from Hayuna. Okay, so if it's possible, can we just reserve the question towards the end, either the end of the presentation or at our Slack channel? Okay. Now I wanted to talk about the reach of the ADA-Exact platform. So primarily, ADA-Exact is a platform of a database of audiences. And I think for advertisers, what is especially interesting for them is the daily reach that is available. In other words, how many devices show up on the programmatic networks that our platform is connected to, right, every day. And right now, we have a daily reach of roughly 41 million devices across 9 countries. And you find that this chart depicting, kind of the distribution of where these devices are on a daily basis. Now, in terms of monthly reach, we currently have about 28 million unique devices across all of the markets for which we have data on. And the markets that we have data on include Indonesia, Malaysia, India, Philippines, Thailand, Sri Lanka, Cambodia, Bangladesh, and Singapore. Okay. Now, the reach that we have in ADA-Exact is achieved with no compromise in quality. One of our philosophy and also a differentiating point between us and our DMP, the other competing DMPs, is that we only ingest curated data sources. Now, you find some DMPs like, for example, BlueKai. They actually have a system of mass acquisition of data sources from independent website publishers. So if you're owner of a very small blog or website, it is possible for you to sell your audience profiles to BlueKai. Now, we don't take data sources just from anywhere. One of the key the twin decision criteria, I would say, in deciding whether a data source is one that we'd like to ingest is whether the data source has quality and whether it has scale. So we're only interested in data sources that have very high quality data on people, and it has scale. In other words, it will incrementally add to our reach. So the primary data source on which ADA-Exact is built is this mobile ad exchange data. So when a advertising supported app is in contact with an exchange, the two systems exchange something called a bid request or an ad tech request. And within the payload of this bid request is a rich set of information about the device from which the bid request is originating. So if you look at where my pointer is pointing to right now, you can see a list of kind of raw attributes that accompanies each bid request. So this includes useful location information like the IP address of the device, the GPS latitude and longitude from which the bid request is introduced. From the IP address and the lat long, some exchanges also provide information like country, state, city and zip code of the device. And of course, timestamp is included, which gives us a way to reconstruct the activity rate of the device, how active the device is. Of interest to our telco clients includes information like the carrier, what telco is this device connected to, and the connection that these bid requests can come from include both Wi-Fi and cellular connections. Now, of particular interest to many categories of advertisers is the app from which this bid request has been issued. In fact, we have seen very interesting work that indicates that the app profile of the user, right, the collection of apps that a user use periodically is predictive of both the user's gender as well as age, and of course other kinds of lifestyle interests. So it's very, very interesting. Now, one thing that is that I want to point out is that when we say app profile, in other words, the collection of apps that is installed on the user's device, we don't actually mean the apps that are installed, because there are many apps that are installed on a device that the user does not use. When we build an app profile of the user, we track the apps that the user actually uses, because it's only the apps that the user use that we will get an ad request or bid request on. Right? So that's a very important fact to remember. I get asked this all the time by outside parties, including clients. How active are the users on these apps? The answer is they are active. That's the only reason why we see them. Now, a second important class of data that we ingest is the data from telco systems. Now, telco data is unique in that it is far more voluminous than the ad exchange data that forms our primary data source. Now, more importantly, it is also a complementary data set. Right? It tells us things about the user that the ad exchange data does not say. So one very important distinction is that the telco data contains data on the interaction between devices on the telco network. So when a device calls another device, that is recorded in the telco network as an interaction. So by computing variables such as the number of incoming interactions, right, and the number of outgoing interactions, we can form a picture of the kind of user that is behind that device. So for example, if a device comprised primarily of incoming interactions and very little outgoing interactions, we can infer that this particular user is some information source, right? It's either somebody of importance in a commercial organization, or somebody higher up in the hierarchy within some kind of human organization, because people are primarily calling in to report or to retrieve information from that person. Now, other things that are interesting includes things like this. So we compute a variable called % nocturnal. So this is the percentage of time that the user is active on the telco network after 7 p.m. Now, this is of interest to marketers and advertisers that are keen to market to people who are active at night, right? So think if you're a retailer, if you're 7-Eleven, right? Your sweet spot is the night shoppers, because that's when a lot of retail stores are closed, and the only place where people can get replenishment of important supplies like food stuff or cigarette or battery is to go to a convenience store like 7-Eleven, which is open 24 hours. So you want to target people that are nocturnal, that are active at night, and this is an attribute that we compute. And then finally, we compute things like the radius of gyration, which is the motion, the width of the motion of the consumer, how far they go from their home location, as well as things like the spread of the telco antennas that they connect to. So this is called the entropy of the antennas. Now, when a user makes a call or does a messaging transaction, they will connect to a telco antenna. And the more spread out the antenna, the more likely the user is to move around a lot. And this has tremendous implications for things like the user's need for motor insurance, personal accident insurance, and so on and so on. Right. So I think we're still at the beginning of exploring the possibilities of using telco data for ad targeting. And so it's very exciting times, I would say. Okay. So I think, of course, the real power is not, each and every one of these independent, data sources operating separately. But the real power is when these are combined. And I'll talk a little bit about our methodology for combining this data. Okay. So we obtain our ad exchange data from an ad tech vendor called MobileWallet. Now, MobileWallet is one of the largest provider of mobile ad exchange data in the world. And we have a very, very strategic partnership with them. In fact, 88Exec, the scaffolding of 88Exec is built by MobileWallet. Now, along with our technical partnership with MobileWallet, they also do a lot of capability transfer to us. They transfer knowledge and source code to us. And if you were previously in the ad operations function or the trading desk function of, say, AdParlor, you would have, on occasions, used and requested a MobileWallet segment. Okay. So today, what we have is we have the complete source code of all of the 130 MobileWallet segments. And this gives us the flexibility to generate these segments in most of the markets that we operate in. Now, I say most because some of these segments require things like a good points of interest database and a good app reference table, which may or may not be available in some markets. So not all of these syndicated segments can be generated across all of our markets. Okay, so so these segments are immediately available, and at least most of it. And there is a work stream that's going on within the 88Exec team to actually output these syndicated segments on a monthly basis into a easy to use database. And then business analysts and non-technical users can then use these segment labels either for campaign activation, or they can use these segment labels for analysis. You can actually use these segment labels to analyze it, analyze your market and the industry that is of interest to you. Okay. So in addition to these syndicated segments, our engineering team is also working on a series of propensity score models to output a whole bunch of user attributes. Now, we call these user attributes audience features. And they're classed into several categories, and these are depicted here in this particular slide. So these audience features range from pretty simple ones like brand visit indicators, which are simply a count of the frequency in which a particular device is found at a brand location, like how many times this particular device was found in a McDonald's or a Starbucks. So it ranges from simple things like this to pretty complicated things. Like, for example, let's take say social influence indicators, for example. So this is the fraction of telecom communications that are reciprocated back to the network, right? So something like this is it's a very it's an interesting attribute, but it requires a certain amount of sophistication to use as well, right? And mostly it is used to craft viral campaigns and influencers, what is called influencer marketing campaigns. So when we see social influence indicators, these are attributes, user attributes that underlie and power viral campaigns or influencer marketing campaigns. So there's a whole bunch of these indicators that we're trying to compute. Underlying each and every one of these indicators is actually a model. So it is not built, these indicators are not outputted by one model, but each of these indicators is outputted by one model. So there is a model that predicts the marital status of a person. There is a model that predicts how many jobs that person holds, if the person holds more than one job. There is a model that predicts the household income index of that person, how much or how high above the average household income does this person's household make, right? Things like that. So each and every one is a model. Right? Now we're targeting starting from 30th of June to start to make significant chunks of these propensity scores available for campaign activation as well as for insights. Okay. Now, I mentioned that it's important. One of the important methodologies that we have developed is a method to fuse complementary data sets together, right? And because we envision that we're going to continually onboard data partners. So it's very important for us to have a systematic way to fuse complementary data sets together, as well as to use it to produce more insights about our audiences. Right? So at the core of our ADA Exec, it's this mobile ad exchange data. Now, if I were to depict the data that we have as in the form of a rectangle, we can think of the width of a rectangle as the number of users or the reach of the data set. And then we can think of the height of the rectangle as the kind of the number of user characteristics or attributes that we can infer from that data set. Right? So if this is the mobile ad exchange data, the telco data will look like this. Right? The telco data obviously has much lesser reach. So across, I guess, our partner telcos, maybe we only have reach of about 100 million devices, 100 million users. And but however, the telco data allows us to infer much more complementary characteristics about the user than it's found in the ad exchange data. Okay, and then we're not stopping there. So right now, the Exec team and the data solutions team is in discussion with data suppliers like MasterCard, ShareDisk, which is the largest provider of social sharing data, and other partner websites which we can potentially partner with. Now, very important category of partner websites which we're trying to speak to and get hold of is online retailers. Online retailers give us valuable information about the category spend of consumers. So these could potentially be very interesting for us. Okay, and of course, when you talk to clients with very, very large in-house data sources of their own, they can also be our data partner, and we can ingest data from them. So I'm talking about clients at the scale of, say, a Tesco, right? Or a large retailer like 7-Eleven. These clients have very, very large databases in of them themselves, and they can be our data partner as well. Now, across these data sets, what we try to do is we try to identify a common identifier. And having this a common set of identifiers, we then do something called identity resolution, which links up all of these common identifiers into one ID that encapsulates and summarizes all of these common identifiers. Now, using this ID, which is obtained through identity resolution, we will have a subset of users for which their characteristics are fully described by all of our data. So we can imagine a subset of users for which we know everything that can be known from the ad exchange data as well as the telco data. And we know things like their category propensity spend from MasterCard. We know their social sharing habits, which is the kind of content that they like to consume from ShareDisk, and our partner websites. Okay, so we know everything about these people. So what happens is that this data set becomes the basis on which we can build supervised machine learning models. So in the terminology of machine learning, this data set is called labeled data. Sometimes it's called training data. Now, with the training data or the labeled data, we will be able to build supervised machine learning models that make inferences across the entire base the known base that we have. So given a device over here at the far end, where we only know their bit request signals, if we have a full set of supervised machine learning models that are trained based on this fused data set, we will be able to make inferences about this device that includes things like their creditworthiness, their likelihood to own a four-wheel vehicle, their likelihood to be a global business traveler, to be a global traveler, their likelihood to purchase a digital camera, things like that. We'll be able to make inferences of that sort on the strength of these models. So one important takeaway, I think, when we discuss this methodology, is that we don't need our data partners to have data that has as wide a reach that we have. So as long as our data partners have reach that are in the low millions, right? Maybe if they have reach of 1 million users or more, this would form a very solid basis already for us to have a serious data partnership with them. Now I'll come to a very interesting but technical point about the difference between lookalike modeling and propensity modeling. Now, in situations where when you are trying to explain the kind of insights that we can develop from ADA-Exact, some of your clients which are knowledgeable may point out that other DMPs do the same thing. Like other DMPs also use modeling techniques to make inferences about users make inferences about users for which data is incomplete from those users that they have complete data on, right? So most DMPs do that, and they do that using a method called lookalike modeling. Now, a very common application of lookalike modeling is out of those audience members that have responded to a campaign, where else can I find similar people that will likely also respond to a similar campaign? So this is a very common use case for lookalike modeling. And so I just want to spend a minute or so to point out the difference between lookalike modeling and the supervised machine learning that we do. So let's take, for example, the problem of predicting employment. So the problem statement is, we want to predict if an audience member is employed, unemployed, or retired, okay, or a student. Now, we make the distinction between unemployed and retired / student because retirees and students have some income, right? But unemployed people generally do not have sources of income, with the exception of unemployment checks, okay? So we want to separate the audience base into these three categories. Now, why is that important? Because many categories of products that are like big ticket purchases, generally they should be aimed at people that are employed, okay? And you will not aim them as students. So if you're thinking of selling a car, for example, for an automotive brand, you will not be aiming this at students, retirees, or the unemployed, for example. All right, so that's an important prediction. So if we were to use, in ADA-Exact, if we were to use supervised machine learning, what we would do is we would collect a number of attributes which we think are predictive of employment status. So in the real world, we would use a very, very large number of attributes. All right, we will use dozens, if not hundreds of attributes to try to hunt for predictors, all right, that correlate with this propensity to be employed. Now, for simplicity's sake, I'm just going to use two attributes, right? Because I can only plot a two-dimensional chart on PowerPoint, and so I'm just going to use two attributes. So attribute number one is number of communications interactions and the radius of gyration. So the number of communication interactions is how many people is this device actively communicating with, all right? And the radius of gyration is how far is this device found moving, all right, within its range of motion, right? How far is this device moving? So the hypothesis is that the further a device moves, the more a device moves around, and the more other devices that this device communicates with, this is a sign that this owner of this device is gainfully employed, has a job, right? And that's why he or she needs to talk to people and needs to move around a lot. Okay, so that's the hypothesis. Now suppose we take these two predictors and we use some kind of algorithm to output a predictive model. And this predictive model classifies people into three categories: employed, unemployed, and retired. And so what you will get an output that looks like this. All right, the model will score and label devices into three labels. The blue ones represent what the model predicts to be unemployed. The red one represents what the model predicts to be, the blue one represents what the model predicts to be employed. The red one represents the users that the model thinks is unemployed. And finally, the green one represents those that the model thinks is retired or a student, like that. So this is the kind of output that you will get from propensity modeling or supervised machine learning. Now, what about lookalike modeling? What will lookalike modeling look like in this particular use case? So what lookalike modeling does is, similarly, in lookalike modeling, users will be plotted on some kind of, plotted in a multi-dimensional space based on their user attributes. So you get this similar plot as well. But what you do is you will identify a group of people for which you know that they have the attribute of interest. So in this case, what we have done is we have identified a small group of people that we know are employed, okay, or mostly employed. And then what we try to do in lookalike modeling is that we try to look for people, other devices that are close to that group, okay? So essentially, this is the essence of lookalike modeling, to find the people or devices that are similar to the people that we're interested in. And by similar, we mean geometrically close, all right, to that entity. Now, straight away, you can see a problem, right? When I use lookalike modeling, and I simply just expand the circle to include users that are close to the group of interest, what I end up netting is I end up netting a lot of users that are actually unemployed or retired. So the problem with lookalike modeling is by just expanding and loosening the targeting criteria, what it ends up including is a lot of irrelevant audiences into the segment. And if you take lookalike modeling to the extreme, if you kind of expand this circle across the entire page, what you end up including is literally everybody. So that's the difference between lookalike modeling and propensity modeling. Now, before I stop for questions, I want to close by summarizing today's presentation by comparing mainstream DMPs with ADA-exact. Okay. So this particular column summarizes the attributes of mainstream DMPs and how ADA-exact differs from it. Now, in terms of the granularity of audience attributes, mainstream DMPs typically identify audiences based on segment labels. So in other words, audience attributes in the mainstream DMPs are segment labels, and these segment labels are yes or no labels. So when a mainstream DMP says high income, low income, what they mean is high income, yes or no. It's just a yes or no label. But in ADA-exact, we're interested in an income index, a continuous index indicating how high or how low the person's predicted income is. So because we're interested in indices, continuous indices, and propensity scores, we allow advertisers to target based on a continuum along a particular audience attribute, instead of just a yes or no label, right? Now, in mainstream DMPs, how audience attributes are generated is that they're based on subjective judgment. So in case of things like income prediction, in mainstream DMPs, how income is mostly predicted is based on the type of websites, for example, that the user visits. But here, what we try to do is we try to obtain labeled data, either from our banking partners, from credit card companies like MasterCard International, or from other sources of curated data that have actual spend information, like, for example, our telcos. And then we use this actual spend information to build supervised machine learning models that predict the income of a consumer, the income indices of a consumer. Now, mobile DMPs, mainstream mobile DMPs include typically a POI database. And as part of our deal, actually, with MobileWallet, we also inherited a POI database from MobileWallet. But what we found is that generally these POIs are very low quality, right? It is not uncommon to find POI database in which the center of gravity of that building is placed in the wrong place. The pin is put in the wrong place. It's put either at one end of the building, as opposed to the center. In other words, it's at the edge of the building and not in the center, or it's completely off. It's actually placed in a street in front of the building. So as part of the effort to actually build high quality audience data, we are building a team of people to manually clean up POI databases, both those that we inherit from Mobile Wallet, as well as those that are available from open sources outside. So we are going to manually clean this POI database so we will have high quality location points of interest data. Right. Now, so the app categories here is a minor point. It refers to the fact that we don't just use the IAB content categorization as the default, and we try to look for better ways of categorizing, including the categorizations that are used in Google Play Store as well as Apple App Store. Right. Now, in terms of attribution, most DMPs outside in the market still support what is called last touch attribution, although a lot of them claim to have multi-touch attribution. But the problem with their claim of multi-touch attribution is that they have very limited view of the online journey of a user. Most DMPs record only clicks as user events, all right? But what we have is we have the frequent location sightings of the user. So not only can we also track the clicks of a user, but we also know the previous locations and other kinds of user events leading to the click, and that therefore allowing us to make a more fine-grained multi-touch attribution that will give accurate credit assignment to the influence of past actions on the user's future events. All right. So I'm going to just stop here. This is the end of my presentation, and I will stop for some live questions. Now, if you have any questions and comments, let me just see if I can identify them. Okay, so I seem to have questions, that typed in from the audience. Thank you for your questions. Now, the first question from Slay, from the nickname Slay, is lookalike audiences created from KNN model, K nearest near. So yes, so most lookalike lookalike models are created from unsupervised machine learning models, such as the K nearest neighbor models, but there are others as well. All right, so now we generally don't use lookalike modeling, as I explained, so we use supervised machine learning models. So KNN will not be something that is in our regular repertoire. All right. Second question from the same colleague is, what kind of model are you using for supervised modeling? For income level, is it a standard model already available, like naive Bayes, or is it a customized model? What method do you use for data normalization and eliminating outliers? So I think these questions, if it's okay for you to drop me an email, I think you can probably find my email in the email directory. We can take these questions offline. Okay, these are more technical questions on the mechanics that behind it. All right. Anybody else that want to type a question? It says there are more questions on the Slack channel. People are posting there, but I'll take the question from Cuckoo. So it says, hi, George, thanks for the insights. Few questions, perhaps you could elaborate further. How do you guys define the accuracy of the POI compared to mainstream DMP POIs? How do you define the basket sizes of the audiences? And this would be extractable, shareable to external to our clients. Now, I'll take the first question first. So the accuracy of a POI depends on its fitness for purpose, okay? So now, in general, a POI is defined by two things. It's defined by the pin, in which it's actually supposed to be the center of the location. And then it's also defined by the radius from of a circle from the center. Now, if you are searching for a POI that is, say, let's say it's a petrol kiosk. It's a petrol kiosk, and you have a pin that is at the air pump, right? That's situated near the air pump, and has a radius of 250 meters. Say, now clearly there's something wrong with that POI, right? It is at the center is at the wrong spot, and its radius is too wide. So it's the definition of a high quality. So notice I didn't use the word accuracy, because accuracy is a very precise metric. I use the word quality, and when we see a low quality POI, it's typically defined by the haphazard placement of the center and a poor definition of the radius. All right, you can see that rampantly in some of these poor quality data sources. And so you can just take a look at many openly available POI data sources, which these DMPs depend on, and immediately you can see the problem. Right. The other thing about the quality of the POI is also the name of the locations. Right. So some POIs have outdated names of streets and the building which we are interested in, and so on. Okay. How do you define basket sizes of the audience? Well, so we don't define it. So basket sizes, I presume you're referring to the average basket size of retailing customers or shoppers, right? So these are obtained from our data partners, which here mostly for retail data, we're interested to work with credit card providers like MasterCard. Right? So they have like millions and millions of records of credit card purchases. Each of these purchases are divided into baskets as well as line items, and they know what's the typical basket size for each of the market centers that they monitor. They don't actually give us the absolute number, but they give us an index that shows whether a particular transaction is above or below the market average, right? And that is good enough for predictive modeling purposes. Okay, so since we still have a bit of time, I'm just going to hop over to the Slack channel. Yeah, where is the Slack channel? I'm going to see what are the questions there. There we go. Okay, so I'm gonna take it from the top. So two comments from Sean. Sean says, must a device receive an ad, or at least make a request for an ad in order for its data collected? Short answer is yes. How does the size of a cell affect the telco data collected? Data collected from femtocells to picocells to microcells. Would microcells be more precise? So now we don't do what is called cell tower triangulation. And the reason is because the precision of the location data of telco locations varies very, very widely, right? So telco data is not very useful as a source for location data. So we mostly draw location inferences from the GPS lat longs that accompany the bit requests, right, that we collect from our ad exchange data. So that is on the error bounds are in the order of 10 to 15 meters. And I think that for most purposes, this is good, right? The next question from William says, when pitching Exact, we are often asked which data sources we use. Can we specify the sources Exact, MasterCard, partner sites? Yeah, well, now, this presentation is for internal purposes only because you are an internal stakeholder. I think you are entitled to a lot more detail than outsiders. But generally, we will not want to expose our data partners. Now, for reasons that you would understand, people are sensitive to being accused of selling user data. All right. Now, the contractual framework which MasterCard operates, the legal framework which MasterCard operates, is entirely beyond reproach. So there is nothing illegal about what MasterCard is doing. But then the perception that is created when people loosely label MasterCard as selling user data, it's probably something that we don't want to draw attention to. So what we would say is that we have data sources that are from mobile app exchanges, as well as from our telcos, and then from other curated second-party data sources. That's all we will say, all right? And they don't have to know much more. Now, you may occasionally encounter clients that have, let's say you talk to the chief data scientist of your client, and they really want to know, like, exactly, can you give me a sample? I want to look at the sample. If they challenge you like this, just refer them to us. Refer them to the data science and engineering team. Don't handle them yourself, okay? Because you don't want to say things that later on will trap you and then kind of hinder your deal, okay? Okay, so now the next question from Atitaya. Kun Atitaya. Right. Besides MasterCard, are we able to have data from Visa? Well, MasterCard and Visa are actually the same company, right? And yes and no. So now, right now, only MasterCard has a very comprehensive data partnership program. And one of the reasons is because MasterCard has the ambition to be the payment infrastructure of the world, all right? And they are working with partners that they feel can be the long-term channels, to realize this vision of becoming the payment enabler of the world. And so for them, data analytics is a very important part of that, to enable their partners so that they will be attracted to use MasterCard technologies as the payment infrastructure for the world. Now, Visa is more like a prepackaged solution already, right? So when Visa works with banks to issue a card or something like that, they sell it as a prepackaged service which banks just slap a label on. But MasterCard is different. MasterCard actually breaks up their whole service into components so that they have a wallet service, they have a remittance service, they have a data service. They break up their credit card business into little parts that you can buy and partner with, right? So the next question from Sean is, for users where characteristics are inferred, is there a flag that marks the characteristic as inferred, and that characteristic is updated with the actual value when it comes available? And these inferences are based on propensity modeling. Don't mind me asking a bunch of questions. I'll probably keep firing them out. No worries, okay? And Sean, you can keep posting questions on the Slack channel and we'll follow through on it even at the end of the seminar. Now, there is no flag because all user characteristics are inferred, okay? So when you get when you use a segment label as a way to identify a user, you are already using an inferred characteristic. When you're using a propensity score that is outputted by our machine learning model, you are using an inferred characteristic. Almost everything, with the exception of the raw data, is inferred, all right? So a much easier way to solve this problem is to say, perhaps we provide a list of raw attributes. Anything that is outside of these raw attributes is automatically inferred, okay? Next question from William. How does Exact compare to other data providers like Oracle, BlueKai? Now, the straight answer is that when it comes to the claimed reach, okay, we are much smaller than other data providers. So if you compare us to BlueKai, to Turn, Lotame, MediaMath, these DMPs all claim to have more than 1 billion reach, more than 1 billion devices, all right? Now, however, take BlueKai, for example. A large proportion of their so-called users or audience members are actually cookie site visitors. In other words, the user profiles are indexed by cookie ID, and typically Oracle has something like 3 months of data on them. Okay, so now think about this, right? How reliable do you think are user profiles that are built on cookie IDs? Take yourself, for example, William. So would you do you leave enough traces in your web browsing on a particular site, right, to allow people to build reliable inferences about you just based on your cookie ID? And bear in mind, each and every website issues its own cookie ID. So we're talking about possibly dozens and dozens of cookie ID, all pointing to that same individual, which in Oracle data, in the Oracle database, will be identified as different people because they're all different cookie IDs. Yeah, so I think you get the drift. Okay, so we have a question from Romatica. How do we define audience populated using propensity modeling is a unique audience? So the ID that we use is the Android advertising ID and the Apple IFA, or the ID for advertising, all right? So this is the unique ID that we use mostly, but of course, we also ingest other forms of ID. So in the case of our telco data, we have a range of telco identifiers, including the IMEI, the MSISDN, which is the mobile number, and so on and so on. So we have a range at the IMSI. These are telco terms, right? And then of course for say MasterCard, we will have a cardholder account number as the unique audience. So all of this, it's all ultimately linked to the advertising ID. We use the advertising ID, which is the Android advertising ID, and the IFA as the unique identifier for each user. And so the propensity score is scored against the advertising ID of the user. William Chan, how can we explain to clients that our data is safe and legit? This is especially in light of Cambridge Analytica, which has terrified some advertisers for going near our data. So I knew this Cambridge Analytica thing is going to come up sometime after my presentation, and thanks for asking this question. So now, let's now talk about Cambridge Analytica, which is really controversial only in the light of the Trump campaign, right? And how Facebook uses that. But the United States doesn't have a very, very good kind of framework for protecting user data. So I think let's go to the gold standard, which is the European Union's General Data Protection Regulation. All right. So this is a regulation that's going to come online in less than a month, right? And well, the short summary for the impact of the GDPR on the ad tech industry is that the GDPR effectively make the entire programmatic ecosystem illegal in Europe. Okay, so we simply cannot store anything. Actually, if you are European, if a DMP based in Europe's jurisdiction, right, you simply cannot store anything that uniquely identifies the user, even the IP address, right? So that's how strict the GDPR is. And so, so clearly, ADA-Exact is not complying with the GDPR, and actually, to be precise, nobody is complying with GDPR. As long as you have some kind of user ID, you're already not complying with GDPR, right? And furthermore, there are all kinds of requirements like, the user, once the user requests for being put on a do not disturb list, all right, or please delete my profile list, then all of the entire ecosystem must delete that user. Now, you can see the problem right there. How is it possible for the entire ecosystem to synchronize and delete the user? We don't have such a synchronizing mechanism for programmatic advertising. So the whole programmatic advertising ecosystem is effectively illegal in Europe, okay? So, but thankfully for us, we don't collect profiles of European devices, or at least I hope we're not collecting profiles of European devices. And so far, we don't operate in European jurisdiction, therefore we don't advertise for European advertisers within Europe. And so I'm not saying that we are, off the hook, but we we have some breathing room, right? We're not, if you are a tech company, if you're a DMP company based in any part of Western Europe right now, yeah, you'll be panicky, all right? But we have some time to define our response to it. Now, I'll give you some tentative, since we're on this topic, I'll give you some tentative kind of guidance on how we're going to respond to it. So that there is the industry, the IAB is developing a tokenizing standard, a standard tokenized impressions, so that individual impressions can be valued without revealing the identity of a user. So there is an effort right now by the IAB to do that, to essentially tokenize every impression. So we are tracking that very carefully, and the moment that becomes a standard, we will adopt it within Exact. Okay. What happens when a device ID travels abroad? This question from Sean, where indices may differ in the market. Someone could be lower mid income or travel in the market. So travelers are travelers. They eventually come home. And most segment labels, propensity scores, whatever, are built on the long run observations of a device, not on 2 weeks of travel abroad like that. How the home location of user identified? There's a question from Rusni. So the home location of the user is the geo cell, which most of the bit requests are found. Okay, so each bit request has a GPS lat long. The geo cell, which is it can be as small as 100 meter by 100 meter, but typically they are like 1 kilometer geo cells. But it can be as small as like I mentioned, 100 meter by 100 meter. That geo cell will be the home cell of the user. Okay. So it's already 6 o'clock. So I'm going to take the last question from the Rusni. So this seems like the home location question all over again. What's the logic behind the home location? Can we similarly identify the work location from the cell ID variable using different criteria? So again, so what we do is we divide the land area of a country into square grid cells. All right, and these square grid cells go to as small as 100 meter by 100 meter. And then home locations and work locations are determined based on the resolution of the cell that we want. So if we say we want the highest level resolution, which is 100 meter by 100 meter, then the home location and work location are the cells with the most number of bit requests during daytime and during nighttime. All right. So during daytime, the most number of bit requests will signal that this cell is where people work, is where that person works. And the cell that is most active during nighttime will be the place that people stay, will be their home, okay? Okay, so let me just take one more question from Sean, and before we close the call, the rest of the questions, thank you for your question, I'm going to answer it offline. So Sean says, Rusni, I'm guessing based on a repeated location based on the time of the year. So Sean's right, okay? So I'm gonna go to Nirali's question very quickly. How do we customize these segments across different industry verticals such as FMB? Now, the first step to developing an industry solution is to identify a subset of problems that we want to solve for an industry. So let's take FMB, for example. All right. FMBs, one interesting problem for an FMB is to increase the catchment area of their stores. So imagine if you're an A&W restaurant, okay, and you have a very distinctive brand with a very distinctive color and logo and everything, and people generally can identify you if you are within line of sight. But what if somebody is within walking distance from an A&W restaurant, but it's not they're not within line of sight to the brand signage. So how can you increase the catchment area of that restaurant? So this is where location-based targeting comes in, and ADA has a range of location-based targeting solutions. So the idea behind location-based targeting is that we identify a location of interest. In this case, we identify the center of the restaurant as a location that we want to draw people into. And then what we do is we define a location-based segment, which is centered around the restaurant within a certain radius. And then that segment, once it's crafted, is then, if devices are repeatedly found in the segment, devices are repeatedly found within the vicinity of the location, they become susceptible to advertising that will draw them into that location. So, then two types of campaigns can be created. Well, one is your typical social media or programmatic campaigns that are based on these location segments. But the problem with these campaigns is that you cannot control the time in which the ads are viewed, right? So you can create a location-based segment, but it could be that by the time the user fires up Facebook or their ad-supported application, they would have been far away from that location already. Now, another more effective solution is to use push notification from our telco media, which is ADA Reach. So ADA Reach has location-based campaigns that will push a multimedia notification or a text-based notification to a consumer if they are within the location of an F&B outlet. So this is an example of one solution to one problem within the F&B sector, which is to increase the catchment area of the restaurant. But of course, within the F&B sector, you will easily identify 6 major pain points that we can help to solve. And by kind of solving these problems in a very decisive way, and then bundling these use cases up into a package, we will have an industry solution. Okay, so thank you for your time for logging into this call as well as listening to me. If you have further questions, continue to post them on ADA Exec webinar Slack channel. For those questions which I do not have time to address today, I will address them, and some of my colleagues will address them offline outside of this call. All right. So thank you very much. And this call is recorded. So if you'd like to review the material they shared with this call, feel free to to obtain. I think Saga will send out a copy of this the link to this presentation, as well as a copy of the PowerPoint that I've used in this presentation. Okay, thanks everyone.